Hi, this is for question number 2, add two numbers. We are given two non-empty linked lists, which represent two non-negative integers. So, and the numbers are in reverse order. I think the image would illustrate this better. So we have a linked list 243 and another linked list 564, and the output is 708. Okay, and how we get this is by adding all the numbers 243, 564. We add it all up, right? But then, well, actually, that's it. The actual number is in reverse, 807. But what we're gonna return as output is just the head of this list, because this is gonna point to that, and that points to that. So one thing to keep in mind is that the input can just be they can have one node each. In that case, we would add them up, but 0 plus 0 is 0. Another thing to keep note is that the length might not equal, but still we would need to add it. So we don't. So fortunately, we are going to have at least one node, so we don't have to check for the input necessarily for edge cases, and the value is going to be between 0 and 9. So I went through this problem once before, but just wanted to do it to jog my memory, because why not? So let's think about it. We have two nodes, and initially when I first thought about this naively, it was like, okay, why don't we just create two lists, right? We'll iterate through the first linked list, create an array that contains all the values, and same thing for the second linked list. Store all the values to a second linked list, array list, and then we'll add it all up, and then we would we would have to reverse all of the lists, add them all up, and then reverse it all over again, and then create linked lists from that. But then when I was thinking about that or trying to implement it, I thought, why can't we just add it from the get-go, like add each number? So for example, add 2 and 5 from the get-go, so you get 7, create a node object and store that in a list. So you sort of save time there. And one thing to keep in mind is that I didn't say this here, but 2 plus 5 is 7, right? 4 plus 6 is 10. So we have a 0 here. We carry over 1 to here, so this becomes 4, or 7 becomes 8, right? So we need to keep in mind that, okay, if it is over 9, then we need to carry over 1. And fortunately, carryovers are either 1 or 0, right? So that's pretty fortunate. So we are going to iterate through the linked list, and I'm going to create a pointer for each one of them. So I'm going to say pointer 1 is going to point to the head of L1, and pointer 2 is going to point to the head of L2. And while P1 and while P1, I'm going to do while P1 or P2. So while any of them are valid, as long as one of them is a node, we're going to keep looping through this loop. And what we're going to do is, and I'm going to create a results array here, result list. I'll say result list, or maybe, yes, why not? Result list, okay? Because we're going to store the nodes there. And I talked about the carryover earlier, so I'm going to say carryover initially is set to 0, okay? Because we don't have nothing to add. We are going to say if P1 and P2, right? If both of them are nodes, then we're going to say, okay, let's say the value is, we said we're going to add them up, right? So P1.val is this, for example, plus P2.val, which is 5 in this scenario. And then let's see, we need to, well, this is thinking ahead of the carryover. We want to add the carryover, but we need to switch the carryover if it's greater than 9. So I'm just going to say plus carryover here. So the value is going to be P1.val, P2.val plus carryover. which initially is 0. So we don't have to worry about that. And then we want to check if the val is greater than 9. This is when we set the carryover. If it's greater than 9, say 10, then we want to set the carryover to 1. Otherwise, carryover can just stay 0, right? And we need to set that because otherwise it's always going to be set to 1. We like when we do the next addition, we might need to default it back to 0. One thing to keep in mind is that I almost skipped this here, but let's say we just add this, right? Let's say it was 4 plus 8, that would be 12, right? So the value would be 12, but we can't actually store 12 in this new node that we're going to create, which is going to be list node val. We can't put 12 into this node. So what we have to do is actually, I'm just going to clump these all together because they're going to add anyway. And then I'm going to have to mod it by 10 because let's say it was 12, right? So what's 12 mod 10? Well, the remainder, right, is 2. So then we're going to add 2 to this new node, and we're going to still have carryover because 12 is greater than 9 set to 1. And then later on, I want to, after making this node, I want to add it plus add that to the result list. So that's how we get the addition of 2 nodes there. But importantly, we want to do p1 equals p1.next and p2 equals p2.next because we're going to the next one. So let's say p1 or p2 is empty because we saw this mismatch here between the input. So you could do the same thing. If p1, then we're checking elif p2, right? We're checking, okay, which one, actually, if p1 and p2, then we do that. Else, we want an else here, right? So if it's not that, then we're going to check if p1, then we can say elif p2. We're checking which one has a node. And we're doing the same thing here. So value is going to equal p1.val plus carryover just by itself, mod 10. And at first I thought we don't need to set the carryover. I mean, we don't need to check the value whether it's going to be greater than 9 because I was like, it's alone, one node. It's like, it doesn't make sense. But I was not thinking about the carryover. What if the node was 9 and the carryover was set to 1 by the previous one? Then you have 10. You have to carry over 1, and we didn't. And I didn't take account for that earlier on. So I'm just gonna copy and paste this because what if val is 10? Then this 10 mod 10 is 0, so we'll have 0. And let's do the same thing here, right? Everything's the same here. We just change the variable names. So for val, we're going to just do p1 only. If val is greater than 9, carry over, same logic. Node, we're creating a new node every time and we're adding that node. So we're just going to copy and paste this because the logic applies to p2 also. I just need to p2.val. And that looks good. And last but not least, I need to say p1 equals p1.next because it might have another value until none of them have a value. So we do this until the condition is like none and none, right? So until all of them are none. So if I didn't miss anything, then we're on a good pace. Good track here. Now I'm confused. Okay, let me collapse this actually. Okay, so we checked that. Now we have our result list. Unfortunately, they are in order now. It's backwards still, but it's in order for us to create a linked list. So we're gonna iterate through them. So for node, actually, let's do range. So I in range of the length of the result list, right? We're going to say if if we're, because we don't want to go out of range, if it is within range, we're going to say that result list that I, this node, its next one is going to be result list I plus 1. So we're setting the pointer to the next one, until we can't anymore. So the last element is going to have none. So okay, and then we just simply need to return the first element here, because that is the head, and it's going to set as, work as a chain to show us what we have. So let's see. It's wrong, and I think I know why. So I'm going to have these collapse still, but the reason why is because, let's say, and you can see from here, 3 plus 4 is 7, but we didn't, so 4 plus 6 is 0, that's right, but we didn't carry 1 over. Why is that? Because at the last elements, we did 3 plus 4, there was no carryover, but carryover is set to 1 because of this. So we need to take account of that, and how we do that is, if carryover equals 1, then we want to add it to the list. We're going to do, so node is going to be list node value 1 because of the carryover, and then we're going to result list set append node. So we add this to the list, and then from here, that didn't work still, because why? If carryover equals 1, that result list equals node. Yeah, why didn't that work? Let's see. Else. Carryover. So carryover can be greater than 1. 0. So carryover is 1. If carryover is 1, we're creating a node, list node, right? List node, and we're appending it to node. That's strange. Let me debug this. I want to see something. So it says the carryover is 0, which is weird. Carryover should be 1 at this point, but we're not seeing that. So let me see what's going on. I think it's because when we first add, this is 0, so it's fine, right? 2 plus 5 is, let's run through this. 2 plus 5 is 7. Carryover is 0. 7 is not greater than 9, so 0, right? Second one, we have 4 plus 6 plus carryover, which is 0 still, which is 10. 10 mod 10 is 0. So val, I see. So when we do 4 plus 6 plus carryover is 0, 10 mod 10 is 0, right? So we get val is 0, but 0 is not greater than 9, right? So what we need to do here is actually something like this. Actually, because I replaced the value of that. So similarly here, I want to replace that and replace that, so we can take account of what it was originally. So that worked. I guess you could make that prettier by storing it, but that's what I was missing. I was replacing the value, and there we have it. We're good. 5%. Yeah, the numbers are iffy. It's 14 now. 7. Okay. But anyway, the runtime of this is big O of, let's say, if big O of L1 plus L2, like how, depending on how many elements they have, because everything else are mathematical operations, and we go through this, but still that's going to be depending on the longer linked list. So that was that. Cool.